Okay, so we've got triangle longer side theorem. This is telling us if we have the bigger side is going to be across from the bigger angle. So we've got the 8, we've got the 5. We know C is going to be bigger than A because it's across from the bigger side than A. Okay, so we've got that. Also, the angles is the one that we looked at before. They're going to give you 2 angles. We know the third angle, triangle sum theorem. We can get that third angle pretty easily. Okay, that third angle is 100. So we can say with certainty which angles are bigger or which sides are bigger than what. So across from the 100, that's the biggest angle. This is going to be the biggest side. AC is going to be the biggest side. The next biggest side is across from the next bigger angle, so the 50. So BC and then BA is going to be the smallest. A lot of the questions you're going to see for this are simply write the side lengths in order from smallest to greatest, or write the angles in order from greatest to smallest. Okay, that's the majority of what you're going to see based on these 2 theorems. There are other things that we can do with it, but the majority of it is, again, just greatest to smallest or smallest to greatest. Just make sure you pay attention to which one they're asking for, whether it's smallest to greatest or greatest to smallest. If you get it wrong on big ideas, check the wording. Maybe you did it in the wrong order. Okay. So that's the big part of it. Okay. Any questions on longer side, larger angle? Pretty straightforward. Okay. Good. So, like I said, most of those are very straightforward. You might see some word problems, some real world situations here, because a mountain always looks exactly like that. So there you go. Yeah, and mountains, of course, are 24 feet tall, 26 feet tall. It's a very small mountain with snow on the top. All right. So again, they're just going to ask you to put those in order: smallest to greatest, greatest to smallest. All right, the next thing that we got to talk about. The next thing that we're going to talk about is I want you to think of a triangle. Okay, I'm going to give you 3 side lengths, and I want you to think to yourself, can I create a triangle based on these 3 side lengths? Okay. So I want a triangle that has side lengths of 3, 4, and 5. Do we think that's possible? It is possible. A 3, 4, 5 triangle. It actually ends up being a right triangle. We'll learn all about that in chapter 9, how we can tell if it's a right triangle or not. But a 3, 4, 5 triangle, that works. What about a 5, 5, 5 triangle? Can we do that?
Yeah.
Of course we can. Equilateral, right? Equilateral triangle. Yeah?
Oh, the numbers. Okay.
The numbers represent the side lengths.
Okay.
Yep. Yep, side length. So 5, 5, and 5. We can create that. Okay. How about, let's say, a 3, 3, 5.
No.
3, 3, and 5.
Well, actually, no.
We know it's
Yeah.
isosceles, right? 2 sides.
Yeah.
It would actually be more like that, right?
Yeah.
3, 3, 5. Yeah, we can do that. What about this one?
Yeah. Actually, no, because yeah.
Talk to somebody. Talk to somebody.
Well, obviously, both sides don't match. Because it only would be, it could have been 4 flushing, but not 5. Because the side ones.
All right. What are we thinking here? Raise your hand. What do we think of this? Jaden?
Well, if the 3, 3, 5 works, then the 2, 2, 5 couldn't because it would be a little bit bigger because the 2 ones are like that and then the 5 one would be like that. And it'd be too big.
What would be too big?
The 5,
The 5 would be too big.
yes.
Okay. Anybody else want to explain further here? Got it?
If you add the 2 smaller angles together, they do not equal more.
Okay. And that's coming from our theorem, right? And that is our theorem that we'll look at in a minute. But if we think about this, 2, 2, 5, if I have a length of 5 here, and then I've got a 2 and a 2, they're not gonna meet. Right, even if I were to swing those down as far as possible to try to get them to meet, they're never going to. Right, it's gonna stop here and here, there's gonna be one in the middle. That doesn't form a triangle. We cannot form a triangle if these two sides don't meet. What if I had 2, 2, 4? Is it gonna form a triangle?
No, it's gonna form straight line.
It's gonna form a straight line, right? Because you have a length of 4, and 2 and 2 is just gonna form a straight line. It's gonna give you a midpoint. It's not gonna be a triangle. Okay. So this is where our theorem comes in. In our theorem, the triangle inequality theorem, which is one that we are going to use quite a bit here, especially today. Our triangle inequality theorem tells us the sum of the lengths of any two sides has to be greater than the length of the third side. What we mean by that is if you add the two smallest sides together, it needs to equal more than the third side. So write something down about that. You can copy it word for word if you'd like. Go ahead and write something down. And then we'll talk further about it. So what we're saying here again is you should be able to add up any two sides, and that number needs to be bigger than the third side. Now really, we only need to check the two smaller sides added together. We don't need to check all of them. Because if you take the biggest side and you add that to anything, of course it's going to be bigger than the rest, the third one, right? So really all we have to check is we need to add the two smaller ones up and make sure that it's bigger than the third one. That's going to allow it to become a triangle. Okay, we had 2 plus 2 equals 4. It's not an or equal to. It's a greater than. It cannot be equal to. It needs to be more than. Okay. If we look at visual representations here, this is kind of what we were getting at. All right, we can have a triangle here of 2, 4, and 5 because those two sides are going to meet. We cannot here because they're not going to cross. Here they're going to cross, but they're going to make a straight line. So it doesn't work. Okay.
It kind of looks like the 3 and the 2, 3 and 4, like the line.
Yeah, I mean, that's because of the thickness of the line. It looks like it meets that entire way, but we know better. All right, so really what this is going to look like is they're going to give you questions where they give you 3 side lengths. And they're going to ask, can this be a triangle or not? So I want you to look at these 3. Think, can they be triangles or not? Okay, for 5, does this say triangle?
Yes.
Yeah, 4 plus 9 is 13. That's bigger than 10. Is this a triangle?
No.
No. Is this a triangle?
No.
No, it doesn't work. So yes, no, no. Good. The other part to this is going to be giving you 2 lengths and asking what could that third length possibly be? So I want you to talk to somebody here. Give you 30 seconds to talk to somebody. What possible values could that third side be?
It could be 5. Because 10 could be longer.
And just because the question mark is the third one doesn't mean it's the biggest. Okay? We cannot assume that that's the biggest side.
So there could be a lot.
Oh.
It could be like.
A range of answers.
why couldn't it be like some?
It couldn't be 100 because 6 plus 10, that is bigger.
Anything less than four,
Well,
and then anything.
oh,
So it could be anywhere from 5 to 6.
So that's part of it. Now we gotta see how small.
oh, wow.
All right. What are we thinking here? Simon?
I think it could be anything bigger than four.
Anything bigger than 4? Okay. So it's gotta be bigger than 4 because like a 5 plus 6 gives us 11, which is bigger than 10. Okay, good. But if I just look at that, if I just say that's my answer, that means X could be 1,000,000. Can X be 1,000,000? Of course not, right? What else can we say about it?
X is greater than 4 but less than 15.
It's gotta be less than, what'd you say?
15 or
No,
16.
16, gotta be 16, not 15, yeah. It's gotta be less than 16, right? It could be 15, because 6 plus 10 is 16, that's bigger than 15. It cannot be 16, because then they're equal. It could be 15.9, that would work, right? So that's why we have to put it all the way up to 16 and not 15. Okay? So there's our answer for that, okay? One more. What's my inequality gonna look like here? Connor?
Greater than 5.
No? It can be smaller than 5. Could it be a 1? Could be 1, right? 5 plus 1 is bigger than 5. That works. Could it be 0? No, you can't have a side length of 0. Could it be 0.1? Yeah. So it's gonna be bigger than 0. What's that have to be less than? 10, right? It'll be less than 10. Here's our shortcut real quick before lunch. Shortcut, subtract them, add them,
Oh.
every single time.
I thought of that.
Subtract
No,
them,
you did.
add them.
So you didn't.
every single time, that's gonna work. Guys at home, you don't have to come back after lunch, we're all done. See ya.
Maybe